Welcome back to the IS IT Governance course. This is the second module. We call this module Evaluating IT Investments. We have two broad goals in this module: evaluate individual IT investments and then incorporate risk in the IT investment evaluation. We will start with the evaluate individual IT investments. Needless to say, IT provides many affordances. So in an organization, there will be many demands to implement different kinds of IT systems. However, there are only so many resources to implement all those projects. So we have to decide which projects should be implemented. So this is about allocating limited resources that will maximize the return of the investment. In practice, this means identifying which projects should be funded so that we receive the value that we are expecting from IT. This means that we have to estimate, that is, evaluate different IT investments. There are three kinds of estimating. The first is an order of magnitude estimate, that is, in this kind of estimate, we have a general idea about what system we want. We only know the top level, high level, broad contours of the solution. This kind of an estimate is a very rough estimate. We may be off by as much as 50% in this kind of estimate. However, after an order of magnitude estimate, we may decide that this is worth pursuing or looking into further. So we get into what is called a budget estimate. A budget estimate will be used to decide whether this project is worth pursuing, and if we decide that this project is worth pursuing, we will allocate the budgeted amount for the next year's investment. So a budget estimate has more details than an order of magnitude estimate, but this is still a top-down estimate, and it can be off by as much as 25 to 30%. Once a project has been approved, then we need what is called a definitive estimate. A definitive estimate, in the definitive estimate, we know individual elements that need to be executed to complete the project. In the Microsoft project terminology, in the definitive estimate, we know work packages that need to be completed to complete the project. So this kind of an estimate is very precise. It will be within plus or minus 5%. Okay, so let's look at the order of magnitude estimate first. To give you an analogy, let's say you have a home and you want to add a sort of extension to your home. So you ask a contractor about adding an extension to your home. Without getting into what you want this extension to include, the contractor may say it's going to cost about $350 per square foot for the extension. This is very similar to a company deciding that they want to consider implementing an ERP system. So they may want to know what is the cost of implementing an ERP system. They start by inquiring with top ERP vendors like SAP, Microsoft, and Oracle to give them an order of magnitude or a ballpark estimate for implementing an ERP system. And these vendors come back and say, expect a project cost of about 1% of revenue. So without getting into which modules will be implemented, what level of customization the company is interested in doing, the vendors will quote a figure like assume about 1% of revenue. The only function of a ballpark estimate should be to evaluate whether it would be useful to get a more accurate estimate. In contrast to a order of magnitude top-down estimate, in bottom-up estimating, we know the work. That is, we know all the individual work packages that need to be executed to complete the project. In between an order of magnitude top-down estimate and a bottom-up estimate is the budget estimate, where we make more detailed estimates to decide whether to pursue a project. The key idea behind a budget estimate is to consider the total cost of owning a system. The total cost of owning a system includes three elements. The first element is acquisition and procurement cost. Acquisition and procurement cost includes the cost of developing the specifications for the system and the actual hardware and software costs. The second element of cost of ownership is operation and maintenance cost. Once a system has been implemented, what are the costs, that is IT labor costs and space and energy and furniture costs to operate and maintain the system. And the last element of the cost of ownership is end of life management. Once the system has lived its life, what is the cost of transferring data from the old system to the new system, and what is the cost associated with physically decommissioning a system. So a budget estimate includes acquisition and procurement, operation maintenance, and end of life management costs. That is the total cost of owning the system. In the next video, we are going to use an Excel based example to look at a top down budget estimate. Thank you.
Welcome back. In this video, we are going to use an NPV based analysis to evaluate an IT investment. The IT investment we are going to evaluate is the anesthesia information management system that is being proposed. I hope you have read the case and are prepared with the background information for this problem. So I have already created an Excel template which has costs and benefits on the left hand side, and on the right hand side I have listed all the key assumptions. All right, so to go over the key assumptions, we are going to use a cost of capital of 7%. The next set of assumptions are about the hospital operations. The annual revenue of the hospital is about $71 million. Out of these $71 million, the operating room generates about 40% of this revenue. In an year, the operating room performs 9,200 procedures across 14 operating rooms, and these 14 operating rooms are supported by 3 office locations. The system, the anesthesia information management system that is being proposed, is going to be used by about 100 people. So 100 people need to be trained about this system. The proposed system has 3 main benefits: drug savings per case, drug savings per case of $32 per case, other savings per case of $100 per case, and the proposed system is expected to increase reimbursement by 1.5%. So the operating room reimbursements are expected to increase by 1.5% because of the proposed system. The costs of the proposed system are, the key cost is the cost per workstation. The operating room workstations cost $8,000 per workstation, and the office workstation costs $5,000 per workstation. The cost of software per workstation is $10,000. The cost of infrastructure is $15,000. The infrastructure in this case is the cabling that is required. The operation and maintenance cost of this system is 18% of the cost of the investment. So for all the hardware and software elements, the operation and maintenance cost, the annual operation and maintenance cost, is assumed to be 18% of the cost of the investment. To implement the system, we require some external help from consultants, and the cost of the consulting is 200% of the cost of the software. So we assume that the consulting help that we require is going to cost 200% of the cost of software. As I said earlier, we are going to train 100 individuals on this system, and the cost of training per person is $1,000. Finally, the server that will be used is the cost of that server is $32,000. So these are the costs. These are the costs and the benefits that will determine the NPV of the proposed system. In the next video, we will start by tabulating the costs of the system. Thank you. Welcome back. In the last video, we saw all the assumptions associated with the anesthesia information management system. In this video, we are going to record and tabulate all the costs of the proposed system. So the broad categories are listed here. So let's get started. So the operating room workstations. So the operating room workstations will be calculated like this. We say equals minus, since this is an investment, and the operating room workstation cost is equal to the number of operating rooms, which is stored in cell P9, and this is always stored in cell P9, so we're going to use an absolute reference, which in Windows is F4. So P9 times the cost of the operating room workstation, which is stored in cell P18, and it is always stored in cell P18, so absolute reference, and that is the cost of the operating room workstation. So this is the initial cost of the operating room workstation. Once the operating room workstation is installed, it has to be maintained, operated and maintained on an annual basis, and so we will record the annual cost of operation and maintenance of the operating room workstations. So again, this is equals, and it is this number, and it is always this number, times the annual cost of operation and maintenance, which is stored in cell P22. So it is always stored in cell P22, so that is F4. So now we have the annual operation and maintenance cost of operating room workstations. So since this is the cost for every year, I can just drag it across the 10 years. All right. The next element is the cost of operating room software. So again, this is equals, since this is an investment, it is minus times the number of operating rooms, which is in cell P9 and always in cell P9, times the cost of operating room software. So the cost of software per workstation is stored in cell P20. So P20, and that is the cost of operating room software. Again, we calculate the operation and maintenance cost of operating room software, which is this value, always this value, times the operation and maintenance cost. The next element is office workstations. So the investment in office workstations is equals minus the number of office locations, which is 3, which is stored in cell P10, times the cost of office workstations. Okay, next let's record the operation and maintenance cost of office workstations. So equals this number, always this number, times the operation and maintenance costs. The next cost is office software, so that is equal to minus number of office locations times the cost per workstation. Okay, then we again calculate the operation and maintenance cost. The next cost is the cost of infrastructure, which is in cell P21, and then we record the operation and maintenance cost of infrastructure. And it is this cost for every year. The next cost is the cost of server, which is recorded in cell P25. And then we capture the operation and maintenance cost of the server. The next cost is consulting and integration. So here we said that the consulting and integration cost is 200% of the cost of the software. So the cost of the software is the cost of operating room software plus the cost of office software, and our total consulting and integration cost is cost of the software times the rate, which is 200% of the cost of software. So this rate is recorded in cell P23. One key point about the consulting and integration cost is that this is a one-time cost, so there is no annual operation and maintenance cost. Finally, the last cost is the training cost, which is the number of people to be trained, which is in cell P11, times the cost of training per person, which is in cell P24. Alright, so now we have tabulated all the costs. So let's calculate the total cost, total initial cost plus total annual cost. So the initial cost is equal to the sum of everything in column C. So that is, we sum values from C4 to C11. So this is the initial cost, and then the annual operation and maintenance cost is stored in cells D1 to D9 for the first year, and we can just drag this every year, drag it across to calculate the operation and maintenance cost for each separate year. Alright, so now we have tabulated all the costs of the proposed system. In the next video, we will look at the benefits of the system and then calculate the net present value of the proposed system. Thank you. Welcome back. So in the last video, we tabulated all the costs of the proposed system. In this video, we will tabulate all the benefits of the proposed system and then calculate the net present value. All right, so let's get started. So the first key benefit of the proposed system is savings in drug costs. So the saving in drug cost is calculated as the total number of procedures, which is in P8, times the savings in drug costs per case, which is stored in cell P13. So that's the savings in drug costs, annual saving in drug costs, and then we drag this across to calculate this number for every year. The second savings is what is referred to as other savings per case. So again, we multiply the number of cases per year divided by other savings per case, which is in cell P14. And we can drag this across to get the other savings for each year. Finally, increase in reimbursement. So we said that operating rooms produce 40% of the revenue of the hospital, and the proposed system is expected to increase the reimbursement rate by 1.5%. So let's calculate this number as operating room revenue, which is 40% of the hospital revenue times a 1.5% increase. Right, so this is the increase in reimbursement, and we can just drag this across to calculate the increase in reimbursement. Now we can calculate the total benefits from the proposed system for each year. So we just sum the three benefits, which for the year 1 is in cell D14 to D16, and then we can just drag this across to calculate the benefits for each year. All right, now we have the costs as well as benefits for each year. So now we can draw the projected cash flow from the investment. So the initial investment is in cell C12. So we just capture this here, and then from year 1 to year 10, we calculate the net benefits as the sum of benefits plus costs. Alright, so we can just drag this to calculate the net benefits for each year. All right, so now we have the projected cash flows from the investment, from the initial investment to the annual benefits for each year. Now we can calculate the NPV of the project. So NPV of the project is the initial investment plus the discounted cash flow from year 1 to year 10. So we are going to use an Excel function called NPV to calculate the real NPV. So the real NPV is the initial investment, which is in cell C12, plus the discounted cash flows from year 1 to year 10, and the NPV function of Excel can be used to calculate the total value of the discounted cash flows. So the NPV function has two parameters. The rate, the first parameter is the rate, which is stored in cell P3, and the next parameter are the cash inflows, which are in cell D9 to which are in cell D19 to M19. Okay, so now we calculate the NPV of the investment as 10 million plus. We can also calculate the internal rate of return of the proposed system. So the internal rate of return can be calculated using the Excel function, which is IRR of all the cash outflows and the inflows. So the IRR is the rate which equates the initial investment with all the other cash inflows. So in this case, the rate is 202%. So in this video, we calculated the benefits, and then we calculated the net benefits, and using the projected cash flows, we calculated the NPV and IRR of the proposed system. In the next video, we will look at what this analysis really means. Thank you. Welcome back. In the last video, we calculated the NPV number. The NPV number is very high. So it looks like this is a very good project. However, this NPV number was calculated based on a set of assumptions. The assumptions are listed here. So before we go ahead and make the investment in the anesthesia information system, the first thing we should do is to make sure that the NPV calculation is robust to changing the assumptions a little bit. So these assumptions were made to calculate the NPV number. So we want to be sure that the NPV is still going to be a good number even if the assumptions were changed a little bit. So for example, the NPV calculation was done by assuming that the operation and maintenance cost is 18%. So a manager may say, what would happen to the NPV if our operation and maintenance cost is not 18% but 20% or 25% or 30%? So Excel allows us to do some sensitivity analysis. So Excel allows us to recalculate the NPV number for different values of the operation and maintenance cost. So let's do that first. So we are going to recalculate the NPV for different values of operation and maintenance cost. So let's say we are going to recalculate the NPV. So the formula for the NPV is stored in cell C21. So I'm just copying this here, and we are going to do maintenance cost sensitivity. Okay, and we're going to recalculate the NPV for different values of operation and maintenance cost. So I'm going to format the cells to be percentage 2 decimal points. So let's say we recalculate for 15, 15, 18, 20, 25, and 30%. Okay, so we will recalculate this formula for different values of maintenance cost. So we select these cells and then say data, what if analysis, and then data table. So we will recalculate the NPV formula for different values of the column input, and our column input is originally stored in cell P22. So what we are saying is we are going to create a new table where the formula is stored here, but we will change the column input that is stored in P22 to these values that we have entered here. So when I say OK, it recalculates the NPV for different values of the maintenance cost. So as you can see here, the NPV is still very good even if the operation and maintenance cost is as high as 30%. So in this example, we did the sensitivity analysis based on changing one variable. Excel allows one to change two variables simultaneously. So let's say we want to see how sensitive our NPV number is if maintenance cost and one other variable is changed. So let's say we want to change maintenance cost as well as cost of capital. So we have assumed a cost of capital of 7%. What happens if the cost of capital is also changed from 7% to 10% and 12% and 15%? So in this example, now I am going to recalculate the NPV by changing the maintenance cost and cost of capital at the same time. So again, the formula is stored in cell C21. So I'm just copying the formula for the NPV, and then we are going to do maintenance cost sensitivity. $15, 18, 20, 25, and 30. So this is our maintenance cost sensitivity. And then here we are going to do cost of capital sensitivity. Seven, 10, 12, and 15. I'm going to center this. Okay, so we will recalculate the NPV for different values of maintenance cost and different values of cost of capital. Okay, so to do that, we will select our space and then do data what if analysis and then data table. So our row input is cost of capital. So the formula includes cost of capital, and that number is originally stored in cell P3. So what this is saying is we are going to recalculate the formula where we are going to change the row input from P3 to the different values we have entered here. Similarly, we are going to recalculate the formula by changing the maintenance cost, which is originally saved in cell P22. So what this is saying is we are going to recalculate the NPV number by changing the value that is stored in cell P22 and instead using the values that we have entered here. So when I say OK, it is going to recalculate the NPV for different values of cost of capital and maintenance cost. Let me just format this to all be dollar or currency amounts. And I'm going to center this. Alright, so now it looks like even when this NPV number is calculated based on different values of cost of capital and maintenance cost, it is still a very high number. For example, even when the cost of capital is 15% and the operation and maintenance cost is 30%, still the NPV is a very high positive number. So to summarize, what we did in this lesson was we took the NPV number and evaluated whether the NPV number that is based on a set of assumptions is robust to the assumption that we are making. In this example, in the last example, we changed two parameters, cost of capital and maintenance cost, and this project turned out to be a good project even when we almost double the cost of capital and almost double the maintenance cost. So the main lesson is we make some assumptions to calculate the financial viability of a project, but then we test the NPV calculation to the assumptions that we make. And if it is still a good project, then we go ahead and make the investment. Thank you.